A lot of today we're going to be talking about vanadium, and I have to ask, how does that contribute to the structural engineering field?
For sure. So I'll give you a fun fact and some trivia on vanadium. For those that don't know what vanadium is, it was discovered in about the early 1800s. It's actually a very common element. It's found in 65 minerals and fossil fuel deposits. And the name vanadium comes from a lady called Vanadis, a goddess, the goddess of beauty and youth. There's several applications for vanadium. The majority of vanadium, about 85% of vanadium consumption is through a product called ferrovanadium, which is a steel.
Vanadium is the unsung hero of modern engineering, playing a pivotal role in industries like aerospace, energy, and construction. From strengthening turbine blades to reinforcing high-rise buildings, this essential element is the cornerstone in the production of high-performance alloys and steel reinforcement, thanks to its remarkable ability to enhance strength, toughness, and resistance to corrosion and fatigue. In this episode, we're joined by Francesco D'Alessio, the Chief Commercial Officer at Largo Inc., to talk about the science behind vanadium's unique properties and its critical importance in structural engineering and the advanced materials. Together, we'll explore how vanadium is shaping the future of engineering and driving innovation across the industries. I'm your co-host, Rachel Holland.
I'm your co-host, Matt Picardal, and this is the Structural Engineering Channel. Francesco, welcome to the show. Thanks so much for joining us. Can you tell us a little bit about yourself and your career journey?
Sure. I was born and raised in Italy, moved to the U.S. When I was in my teens. I've spent the last 20 years in vanadium. Prior to this, I was working, my first few days in the vanadium world were working for Evraz Group, one of the largest Russian vanadium producers. I had a small stint in a trading company where I traded several commodities. And then after that, I had a few years in the coffee industry. And then with Largo, decided to set up a direct sales and distribution network for their commercial department. I was brought in to go to Largo in about October 2019.
So you did grow up in Italy.
I did.
Where
Yes.
in Italy did you grow up?
I grew up in Rome,
Okay.
Italy, small
Okay.
city.
Awesome. I
And
did
then I
my
moved
study
to-
abroad in Florence. So
Oh, you did?
yeah, like a very short time period there, but yes.
Yeah, it's also a beautiful city. Yeah, I moved, and then I got my executive MBA from Bocconi in Milan, and while I was living in Switzerland. And then obviously I moved back to the U.S. to develop the U.S. market for Largo. And then since I've been with Largo, I took several roles. Still currently the president of the energy division. And obviously I'm the chief commercial officer for Largo, and I'm also CEO of our Largo physical vanadium entity in Canada.
Okay, so a lot of today we're going to be talking about vanadium, and I have to ask, for how does that contribute to the structural engineering field? So like, how do we tie these together? And especially when it comes to, I'm sure you're going to talk a little bit about it, but like steel reinforcement and things like that.
For sure. So I'll give you a fun fact and some trivia on vanadium. For those that don't know what vanadium is, it was discovered in about the early 1800s by a Spanish-Mexican called Andres del Rio. It's actually a very common element. It's found in 65 minerals and fossil fuel deposits. And the name vanadium comes from a lady called Vanadis, a goddess, the goddess of beauty and youth. And the reason for this is because of the various beautiful colors and compounds that vanadium produces. There's several applications for vanadium. The majority of vanadium, about 85% of vanadium consumption is through a product called ferrovanadium, which is a steel additive which increases the strength in steel. It was been used historically for many different applications, from axles and bicycle frames, crankshafts, surgical equipments, and the construction is used mainly in rebars and I-beams for bridges, building tunnels, automotive parts as well. And it's also used in ships and in pipelines. There's two major groups of steels that use vanadium. One is high carbon steels, and the other main group of steel products is high-speed tool steels. Just to give you guys an idea about one, if you add a pound of vanadium to a ton of steel, you can increase the strength by about 40% or more, right? So it's a strategic product, and it's used a lot, as you've seen probably in China and in Japan. There's a lot of regulations in using vanadium and rebars for anti-seismic regulations, right? And this has been driving year-to-year growth in demand in vanadium into the specific steel applications, right?
Yeah. Yeah, it seems like I know I'm here in California and we do have a lot of seismic activity too. And yeah, sometimes we do specify those higher strength steel. And I'm guessing that's where vanadium comes in. And and it seems like with China, and I think you mentioned Japan too. Oh, go ahead, Rachel.
I was going to just ask with that, like when you were saying like you add, a certain amount to that much steel that makes it that much stronger. Is it a standard additive to all steel and like it's just smaller quantities or
Yes.
like
Yes. So to give you kind of a range, high carbon steel is about 0.15 to 0.25% V. I call it the vanilla extract when you're making a cake.
okay.
It's not elegant. You just add a little bit of, and it does magical things, right? And then if you're looking at tool steels, it's about 1 to 5%, right? So very minimal amounts, but can drastically have an effect on the quality of the steel, right?
Interesting. Okay, so like just in general, like around like in America, like all, steel that's being produced, it's that number that you just said, the point oh one to point oh
If
two
you're those
five.
two categories of steel groups, yes, correct. There are many different applications. There are a lot of uses that most people don't know about for of vanadium. And then obviously the other major contributing segment that most people don't know about is aerospace applications, right? Which
Right.
is when vanadium is added and basically increase the strength and the temperature stability of titanium, and when it's mixed with aluminum and titanium alloys, right? That the uses for that are jet engines, high speed airframes, defense missiles, rockets, drones, hypersonic missiles, and even an F-22 and an F-35 has to have vanadium in it. So a lot of people don't know kind of this is a secret sauce ingredient for a lot of very strategic applications, both in the defense, but also on the general civil applications for what we need to build in the US, right? And
Okay.
across the
Yeah,
world.
that's cool. It seems like it's pretty much everywhere in terms of infrastructure and even things that we don't even know that have it. So that's pretty cool.
Yes. From your tool wrench in your toolbox to implants as well, right? So, but obviously, a lot of people, when they get an implant, they'll look at what's the content of vanadium inside there.
Yeah.
Did you see a shift in maybe the market trends with let's say countries requiring higher, right? For example, the rebar standards. Do these like how do these influence the I guess the industry and material choices? Does that affect it in any way? Maybe the supplier demand.
Yes, for sure. Like supply and demand is obviously the biggest indicator, right? If you look at what's happening in China, they passed the policy of increasing the grade of the rebar. But ultimately, it's directly correlated to steel production and consumption, right? So, yeah, proportionally, you'll need to use a lot more vanadium. But obviously, if the overall steel production and consumption doesn't continue to grow, it doesn't stabilize, then you're not going to see that effect, right? But yes, we are seeing increasing requirements for producing higher quality steels and more environmentally friendly steels, right? So that's across the world. And I think we're seeing the biggest shift now in China and trying to pursue this market to compete mainly with Europe and North American steels. And this is obviously having an effect in the consumption of various different types of alloys, right?
Interesting. So steel supply is a big part of what I do because we make metal connectors. That's a big part of our job, but I don't get into the supply chain stuff of it very often. I just, I work on the engineering of the connector side of it. But with all the things that you're saying, it's just interesting how all the geopolitical factors can disrupt the availability of these materials, right? So how can engineers who are maybe not as deep into the supply stuff as you get, how can they mitigate risks related to the vanadium supply constraints?
Well, it's a very interesting topic because this is happening across several commodities throughout the world now, right? If you look at specifically vanadium, about I would say 65% of the world's vanadium production is in China. 16%, around 16% is in Russia. Brazil is about 5%, meaning Largo. We're the only producer in Brazil. And then South Africa accounts for about 7%. But one of the two vanadium producers in South Africa right now is experiencing challenges and potentially entering into bankruptcy proceedings, right? So they shut down production. So that has a major effect because out of the outside of Russia and China, there's only 3 vertically integrated mines, right, that can produce vanadium from direct mining, right? The other major producers of vanadium are, as a byproduct of steel production, steel slag, and that's Russia and China, right? And then the balance is really created by production from spent catalysts, so secondary recycling of vanadium. And there's several players that play into that space, and that's kind of spread out throughout the world. But if you look at
Okay,
it,
so wait, I want to break this down a little bit more simple because
sure,
this is pretty far outside of my wheelhouse. So you're saying you can mine it?
yeah,
It's a off product of producing steel,
yes. So it's
and
either
it's
produced from steel making as a byproduct, because obviously you're making steel and you obtain steel slag. So it's as a byproduct of steel making, and that's
okay.
by far the largest, let's say, contributor and producer. Right, about 70% comes from steel slag, and then you have direct mining of magnetite ore, which is about 18% of the global market. And then the balance, a little bit the balance is really from flue dust of heavy oil or as a byproduct of uranium mining. But by far the largest, let's say, contributor to the supply is as a byproduct of steel slag. And the major producing countries for that are Russia and China.
Interesting. Okay.
So that it tells you the critical aspect of this, because there's a lot of concentration in a few countries. And in terms of outside of Russia and China, there's only 3 vertically integrated miners that can produce this, right? The rest are processing secondary materials, right? And this is something to definitely keep an eye on. There's a lot of, when looking at procurement strategy, there's a major disconnect really from the finished product to really mapping out the full supply chain and where those ingredients come from and what is the risk assessment for those specific ingredients for the products that need to be made, right? So sometimes the supply chain is so long that there's a disconnect. And that is something that people are paying more attention to, the shifting geopolitical dynamics and assessing, how critical is this element for the products that I make today, right? And is it easily accessible in the future? Are there other deposits that will come online? How fast can they come online versus are they currently producing, right?
Yeah. That's
And so when you were talking about the vertically integrated, your company is one of them, one of the 3?
Correct. So
Okay.
we are by far the largest high purity vanadium producer outside of Russia and China, and we're the only producer in Brazil. So there's also different qualities of vanadium that you can produce. So because of the quality of our ore, we can produce high purity vanadium, which is required for aerospace and chemical applications, and also for vanadium electrolyte for the batteries. And we are, let's say, by far the one of the largest suppliers for the aerospace industry in North America and in Europe, right? And then from a steel perspective, you don't need as high a quality for vanadium pentoxide, which is the product that then gets turned into ferrovanadium for the steel industry. But again, because of trade flows, there are sanctions against certain origins. There's tariffs and duties against certain origins. The world is fastly shifting on these trade flows and how those can affect the supply to any specific country based on the origin and based on the quality of the product, et cetera, right?
Yeah, and it looks like you were mentioning the quality of the vanadium. I believe Largo has was it the Maracás mention mines, and is that one supposedly some of the purest or highest quality vanadium globally? How does that how does that even happen? You just found a mine, or is it the process that you get the purest vanadium?
Yeah, it's very interesting. So we are the only mine that came online in the last 30 years, right? So that shows the complexity of getting a project to come online, right? From inception to actually producing, right? So there was a lot of assessment that was done on the deposit for many, many, many years, right? And it was identified that the quality of the ore was superior in terms of vanadium content, obviously justifying the investments and the financials behind the project, right? Now, there's plenty of vanadium available throughout the world. There's many other deposits throughout the world. The question is closely monitoring the supply-demand balance and what is the right time for those projects to come online, right? And do they have the right economics based on the content of vanadium and the cost to extract it, right? So it's something that needs to be very carefully analyzed because it takes several years to get an operation online and a very large investment, and it's not easy. As I said, we're the only ones that did it in the last 30 years, right? In vanadium.
So Largo's has control of the entire value chain, right? Can you kind of explain what that means?
Yes. So obviously, when you're the consumer, a final customer, you want to understand that there's stability of supply, right? And that you know where the material is coming from, that the quality is consistent. So we produce out of our mine in Brazil, and then we ship our products internationally and also domestically. The Brazilian market is a large consumer of vanadium as well in the steel industry in Brazil. And then you have to strategically place the units based on obviously the demands of the customers. Most of them buy under long-term contracts, specifically large consumers. It's yearly contracts. But obviously having direct access to the raw material and having also a direct sales and distribution network, we can talk directly to the final customers and address their needs directly, right? By warehousing material close to their facilities, having material, having constant communication, understanding their forecasts and needs, and closely adapting to the market. And it also ensures to the customer that they gain as much transparency as possible on pricing and quality because they can control where the material is coming from, right? And again,
Okay.
this also ties into some of the geopolitical factors that we discuss on
Right.
origin. Is it a Western-friendly origin, right? Or is it a country that is currently sanctioned? Or is it coming? Is it product that has been relabeled, right? So there's a lot of different factors that customers ask for when
And
assessing a
because you
supply.
guys have it from like origin, like out of mining it all the way through to when the customer,
Correct.
gets it, that obviously then helps like the quality and
Hmm.
Correct. Correct. Specifically for aerospace applications, there's a long qualification process that you need to go through. Some customers even require a lot by lot sample, right, to ensure that the lot that you're shipping sample is reflective of the lot that actually ends up being shipped, right? Because quality is extremely important, specifically in the high grade, right?
right.
But yes, if you're talking about security of supply when you're talking directly to a producer, it gives a certain level of extra confidence to the customer, right, about
Definitely.
securing supply, right? And that's happening across commodities. You're seeing more and more end users trying to directly access producers, right, to ensure continuous supply and navigate these challenging markets together of supply and demand, right? Adapting
Right.
consumption and giving forecasting to the suppliers so that one side doesn't bring too much material or too little, and you can adapt to the needs of the market, right?
Yeah. Interesting.
I know in the AEC industry, there's at least in the US, there's a push for environmentally friendly, clean energy, net zero goals. How did that affect vanadium, or how is vanadium even contributing to that?
Well, obviously, if you need, if you use less steel to produce the same product, right? Then obviously you're contributing to carbon footprint that way. Another major contributing factor is the fact that vanadium is currently being deployed as an energy technology as well, right? And vanadium redox flow batteries. I think if you pay attention to what's happening in China, there's very large deployments of stationary storage of vanadium redox flow batteries as an alternative technology, which is a long duration energy storage technology for batteries that can last to 30 years with no degradation and non-flammable, non-explosive. So very interesting technologies that have been around since the late 80s, early 80s. And you're seeing this as an alternative to lithium, right? So lithium is being kept for, let's say, shorter duration energy storage, 2 to 4 hours. And anything above 4 hours, vanadium is becoming a very prominent player, specifically in the Chinese market, right? Largo has taken steps towards entering that market we just entered into a joint venture with Striken Energy, and we are finalizing the closing of that transaction. And we believe that vanadium flow batteries could also be an alternative for the domestic market because vanadium electrolyte is fully recyclable. So at the end of life of the battery, you can take the vanadium electrolyte and reuse it into another battery, right? So happy in the circular economy. And then obviously Largo, as you know, we comply with international standards of sustainability, and all our partners, we make sure that they comply as well. And you're seeing that the industry overall is becoming much more sensitive towards securing supply from producers that are compliant with sustainability practices, right? It's even becoming a requirement when you're registering as a supplier with a specific customer, right? And some customers won't purchase unless you can check the boxes, right?
Interesting. So it seems like the areas in which you can use vanadium is just like continuously growing with the batteries and different things like that are coming about. So the demand is, projected to grow and grow, whereas like the mining is that kind of like lagging behind the demand for it.
Well, I think if there's a fast adoption, as you've seen, and there's several reports that were published by the IMF and World Bank that people can research online, but the projections are if this becomes a viable, large scale and adopted technology for energy storage, there will be a shortage of supply of vanadium. I would say in the conventional industry, supply and demand balance has been pretty stable. Currently, mainly driven by a slower Chinese economy, we've seen vanadium prices being softer. That lasted for the whole second half of last year. But if you look at a longer term picture, yes, I think the adoption of vanadium in all the products that we just mentioned, even in aerospace and defense applications, plus adding this energy storage component, there will be a shortage of vanadium in the future, and that's validated by several reports in the industry. The question is how fast, and then the second
Yeah.
question is how fast can that gap be mitigated by additional supply of vanadium coming online. As I mentioned, there's several deposits. Some are more advanced than others in coming online, but there's no other producer that has come online in the last 30 years. So,
Right.
and obviously these companies are closely watching the dynamics of the market to find the right time to come in, right?
So how like from a structural engineering standpoint, like for Matt and I and in our industry, how should structural engineers plan for, or should they plan for material shortages in like the coming decades and how they do things?
Yes, I think there should be, and the government is trying to do the same thing on, for example, in the U.S. with the DLA, the Defense Logistics Agency, and other stockpiles, and looking at how to secure some of these commodities, right, in different ways. But for sure, I think one is assessing the whole supply chain, looking at existing suppliers and vendors, and assessing the growing needs of vanadium specifically in the future, and how to mitigate that and how to secure supply, right? And having this transparent conversation with the supplier, because most of the time your vendors will have access to that information and will know, right? Will know what's coming and if there's a new producer coming online or not, right? So I think it's really the community needs to familiarize themselves with what are the critical products without which you can't produce your finished products in a specific industry, and understanding, what is the concentration of supply? Where is it, right? Familiarizing on the origins of the product and how much of this product is controlled by a specific country or a specific region or a specific application. That's step number one. And I think obviously closely watching, there's a lot of data that's published from pretty much most commodities, right? The supply demand balance, but closely looking at the statistics. And I think people are starting to pay much more attention, including national governments as well, from a strategic perspective, right?
Yeah. Interesting.
Yeah, and was there? I think this was like, I know I had a sustainability question, but I think you answered it in terms of, if you have stronger steel, you're going to have less steel. So in terms of like sustainability, I think
Correct.
that's how this contributes to that. And from a structural engineering perspective, as an engineer, uh, I'm just curious about your thoughts about, since we're kind of in the end product, right? We specify rebar or steel, and we don't really think about where the steel comes from or what it takes to make that steel. Is there anything that you wish structural engineers would appreciate more about your field and industry? I know you talked a lot about logistics and how to even get vanadium. You get it from a mine or different places. Like, is there anything else that you wanted to share with
Yeah.
engineers that, hey, this takes a lot of work and where it comes from?
Well, we've seen that usually, when you have your procurement department that works closely with the production, right, and a specific facility, and also sales, the integration of communication between those three departments is pivotal, right? Because obviously the salesperson is going to be focused on meeting their expectations of their customers and lead times, right? And the production department has certain milestones and targets and KPI to meet those orders. And then the procurement department obviously has priorities that are to minimize inventory, right? And to secure supply, right? So the critical communication between those three departments is a major factor in understanding any gaps and inefficiencies in supply, right? And how much do you need? When do you need it and where do you need it, right? And I think we've lived in a world has been pretty comfortable. And I think the first lesson that everybody got was COVID, right? And how that impacted supply chain and logistics specifically. And we're still seeing the repercussions and some of the effects from that, right? So also going back to what I was saying earlier about understanding where are your suppliers? Where is this material coming from? What are the lead times, right? How much does it take to process this into the semi-finished product? For example, how long does it take to convert vanadium pentoxide into ferrovanadium, which is the product that's used by the steel mills, right? And understanding those lead times will allow the customers to provide better planning, right? Internally within their departments, right? And the production team and the sales team in their respective companies. But I think that's the best way, is to understand what are critical products that especially we're sourcing internationally, and how fast can we get them, right? And what kind of impact would that have on our sales orders? Because a lot of times the misconception is, well, no, I'll find it. I'll just find it. And, you pay enough and it'll show up, right? But the reality that we've all seen is that hasn't been the case. And we've learned our lessons the hard way on other products. Like, for example, what happened with semiconductors, right?
Yeah.
Yeah. Another question for you, Francesco, is like in college, and Matt, you could probably relate to this too, but I remember like studying a lot, like the different additives for concrete. Like, you add a little bit more of this and how does it change the concrete? And like you take a little bit of this away. And with that, you even like, you get into like costs of some of these additives, like, to try to figure out like what's the best mix for strength and value and cost effectiveness and all these different things. And I don't remember ever doing that with steel.
Yeah, I don't either.
Matt, I don't know.
I just know concrete.
College, like I don't remember that. So yeah. And so I'm just curious, you talked about like, it's a small percentage of like all steel, but if you want a high strength steel, you can like increase that percentage. And how does that change the pricing for the end user? Like, is this one of the more expensive additives, or is it?
If you look at the overall steel price, in the amount of vanadium that you're actually adding to the product, right? It's so small versus the value that you generate out of it, right? So I think it depends really on, for example, how the steel customer is pricing, right? Are they passing that cost straight through with transparency, or are they building that cost in? The biggest factor is when you start having major fluctuations in the index, right? So if you look at the vanadium industry, the majority, as I mentioned earlier, the majority of the business is done under long-term contracts with a formula that's tied to an index. That index is affected by spot transactions, which are usually smaller size orders, right? That ultimately end up affecting the whole index as a whole, right? Because the longer term contracts are tied to an index plus a premium or minus a discount depending on the product, right? So you have a few spot transactions that are affecting kind of the broader market pricing. And those sharp fluctuations in pricing curves are obviously something that end users are not happy with, right? Because it affects the stability of the final product and the price into their product, right? So I think, obviously, the communication between intra-departments, right, and an understanding how much of this cost, contributes to the final cost of the product. Some companies are much more transparent with their sales department. Others, there's a bit more of a disconnect. So I think fostering that level of communication and assessing risk and assessing the impact on cost is crucial. And in terms of actual applications, I think some companies do a better job than others in research and development. There's a lot of organizations. There is, for example, in the vanadium, there's a vanadium producer consortium called Vanatech, where a lot of technical published papers are posted online. It's called vanatech.org. There's also a lot of interesting information on the vanadium supplier base and data, right, that customers or anybody that's interested in vanadium can access. But I think it's something that is constantly evolving. And I think really talking to your peers and others that are producing similar types of products, I think it's something that we're seeing a lot more versus kind of the old school mentality of we're all enemies and we're not going to share. We're seeing a lot more constructive and unison kind of communication to make this a better world and advance developments in technology, right?
Okay, final question. What advice do you have for structural engineers who are leveraging advanced materials to innovate and improve the resilience and sustainability of their designs?
Oh, that's a big question. I would say, again, talk to your suppliers, because a lot of times we become informed of what others are looking at or looking to use our products for, right? So sometimes you get a preview. There's a lot of organizations, for example, you look at DARPA or other institutions that are running consistent research onto different applications or for products like vanadium. And I think we will become more familiar with what those requests are, because a lot of times we'll get a sample request for or specific chemistry or a question that we haven't received before, right? So I think talking to your suppliers can open up a lot of different ideas on the uses and potential use cases of vanadium, simply because we're exposed to a myriad of customers and applications, and we can also act as a potential networker, right? And facilitating those kinds of discussions. And there's a lot of experts in the vanadium world, technical experts that are still very active and doing a lot of research with universities. So I think looking specifically for those experts can then bring that level of research and knowledge internally into your organization, and specifically look at details, for example, in this case for vanadium, and how it can benefit the steel grades that a customer is producing or the various types of product in its applications. Because a lot of times it's untapped knowledge, I would say, right? And there's a lot of people that have very, very industry-specific knowledge on a specific product that wish they could do more or wish they could pass on that knowledge. And a lot of times it gets lost, right?
Right. Okay. Well, awesome. Thank you.
Thanks so much. That was really cool. I appreciate that, because, it's something that we work with every day in our industry, but I barely heard of vanadium. So you telling me about what it is and how it's in all of our products already, that's really cool. And telling us about the supply and demand of what actually goes into that was really cool. So I appreciate it.
Thank you very much. Nice to meet you both. Thank you for your time.
I hope you enjoyed the episode today. We'd love to hear your feedback, comments, and or questions. To leave them, please visit structuralengineeringchannel.com. There you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources or websites mentioned during this episode. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcast. Until next time, we wish you the best in all of your structural engineering endeavors.